Hello everyone. In this video, we are going to have a look at a high-level overview of the role of Kubernetes in today's software architecture. This is going to be an introduction video to Kubernetes. We are not going into specifics of anything, but a high-level overview of everything you need to know to get started with learning Kubernetes. Before we dive into how Kubernetes handles modern distributed applications, it's crucial to understand where many applications started with a monolithic architecture. Historically, software was developed as monolithic applications. These are large and self-contained units ready to operate independently from other systems. Think of monolithic applications as a single self-contained unit, like a giant block of code where everything is interconnected. Let me break down the three main components that typically make up a monolithic application. So the first component is the user interface. At the top, we have the user interface or a UI layer. This is everything you see and interact with, the buttons, the forms, and displays. In a monolithic application, the UI code is bundled together with everything else. Whether you are looking at a web interface or a desktop application, it's all part of the same package. The other component is the backend software. Moving down, we have the backend software, also known as the business logic layer. This is where all the processing happens. It handles things like user authentication, business rules, data processing, application workflows. All of this logic lives in same code base, tightly coupled with both the UI above and the database below it. So the final component is the database. So this database layer is where all the data is stored and managed. In a monolithic application, the database interactions are typically handled through direct connections from the backend code. While this architecture might seem straightforward, it comes with some challenges. Scaling becomes an all or nothing affair. It will be very tough to scale this, and updates require deploying the entire application, and team collaboration can be complicated since everyone works in the same code base. And a single bug can potentially affect the entire system. So the monolithic software is difficult to maintain and update, leading to prolonged release cycles. On the other hand, the modern software architecture has shifted to a more modular approach. Today's approach is fundamentally different. It's more modular, more flexible, and better suited to our rapidly changing technological needs. This is called microservice architecture. We use microservices in this architecture, the building blocks of modern applications. Instead of having one massive application, imagine having multiple smaller and independent components working together harmoniously. So each microservice focuses on a specific business function and can be developed and deployed independently, has its own dedicated resources, and can be written in different programming languages, scales independently based on demand, and this architecture greatly simplifies the maintenance and updates, resulting in shorter release cycles and ability to deploy new features more rapidly. Additionally, these are well suited to cloud computing environments. Nowadays, modern applications consist of tens, hundreds, if not thousands of these building blocks. This introduces a crucial question: how do we deploy, maintain, and update them? The answer is, of course, via containers. Each component is deployed or delivered in its own container, which includes all the prerequisites needed to run that component. How do we manage all these containers and ensure that they operate correctly and keep their versions up to date? This is precisely the role Kubernetes plays. Kubernetes takes care of maintaining, updating, and monitoring containers running your microservices. Imagine that you have a container that crashes. Kubernetes immediately notices this and springs into action, starting a new container to maintain your application's availability, like having a self-healing system. Your application keeps running while any updates are being applied. It ensures zero downtime deployments by maintaining some minimum number of running pods. And then comes cloud nativeness. Kubernetes is cloud native, but what does that really mean? Let's break this down into simple terms. It's a comprehensive approach to how we build, deploy, and manage modern software, specially designed for cloud environments. Think of it as creating applications that are born in the cloud and designed to thrive there. Clouds provide infrastructure like virtual machines for computing, networks to connect to these machines, and storage that all machines can access concurrently. All of this infrastructure can be scaled, which means that we can lease more or less of each component independently of each other. For example, if we currently use 3 virtual machines to run our application, we can add 2 more machines and use them immediately. We can also purchase more storage for our application without increasing the number of virtual machines. Now, a cloud native application has been designed to use the scalable infrastructure efficiently. One way to achieve this is using containerization and Kubernetes. Kubernetes is cloud native, which makes deploying and managing your application very simple. It also enables easy scaling of applications. Now let's talk about how you can actually get your hands on Kubernetes. Here is something interesting. Kubernetes started as a Google project, but they made it open source, meaning it's available for anyone to use, modify, and improve. While you can download Kubernetes directly and install it yourself, I'll be honest, the installation process can be complex. It's like building your own car from parts. So it's possible, but it's challenging. This is where cloud providers come in. Most major cloud providers offer Kubernetes as a managed service. They handle all the complex setup and maintenance, letting you to focus on actually using Kubernetes rather than managing it. You will often see Kubernetes written as K8s. This is not a typo, it's a numeronym where the 8 represents the 8 letters between K and S in Kubernetes. It has become the standard shorthand in the community. Whether you choose to install Kubernetes yourself or use a managed service, the important thing is that you are getting the same powerful container orchestration platform that's becoming the standard for cloud native applications.